Look down at your hands. Look at the device you are using to watch this video. Now, look out the window at the Earth, the clouds, and the sun. Everything you have ever touched, seen, or interacted with. Every mountain, every ocean, every planet, and every shining star in the night sky is made of the same basic stuff. Atoms. Normal, observable matter. Baryonic matter. For most of human history, we arrogantly assumed that this normal matter was all there was. We thought that if we built a powerful enough telescope, we could eventually see everything the universe had to offer. But in the last century, astrophysics discovered a terrifying and humbling truth. All the stars, all the galaxies, all the glowing gas clouds, and all the black holes, everything we can see with our most advanced instruments, makes up roughly 5% of the universe. So, what about the other 95%? It is completely invisible. It is untouchable. It is a vast, shadowy realm made of two mysterious components that are locked in a cosmic battle for the ultimate fate of reality. We call them dark matter and dark energy. And today, we are going to explore the unseen architecture of our universe. Let's start with the first piece of the puzzle, dark matter. To understand how we discovered something invisible, we have to go back to the 1930s and later to the groundbreaking work of astronomer Vera Rubin in the 1970s. Vera Rubin was studying the rotation of spiral galaxies, much like our own Milky Way. According to the laws of physics, specifically Newtonian gravity, objects that are farther away from the center of mass should orbit much slower than objects close to the center. Think of our solar system. Mercury zips around the Sun incredibly fast, while Neptune plods along very slowly. Rubin expected galaxies to behave the exact same way. The stars at the very edge of the galaxy should be moving much slower than the stars near the dense, bright galactic core. But when she measured the velocities of these outer stars, the data made absolutely no sense. The stars at the extreme edges of the galaxies were moving incredibly fast. They were moving so fast that based on the amount of visible matter in the galaxy, the gravity shouldn't have been strong enough to hold them. By all laws of physics, these spinning galaxies should have ripped themselves apart, flinging their stars out into the empty void like sparks flying off a spinning wheel. The missing mass problem. The only logical explanation was that there was more mass in the galaxy than we could see. A lot more. In fact, to keep these galaxies glued together, there had to be roughly 5 times more invisible matter than visible matter. Scientists dubbed this mysterious substance dark matter. But the name is actually a bit misleading. It is not dark like a black cloud of dust that absorbs light. It is completely transparent. It does not interact with light at all. It does not reflect light, it does not absorb light, and it does not emit light. Furthermore, it does not interact with electromagnetic forces. You could walk right through a wall of dark matter and you wouldn't even feel a breeze. If it is completely invisible and untouchable, how do we know it is actually there and not just a mistake in our math? The answer is gravity. Dark matter may be invisible, but it has mass. And because it has mass, it bends the very fabric of space-time around it. Imagine looking at a distant galaxy, but between that galaxy and Earth, there is a massive cluster of dark matter. As the light from the distant galaxy travels toward us, it hits the warped space-time caused by the dark matter and bends around it, like light passing through a curved magnifying glass. This optical illusion is called gravitational lensing. By observing how the light from background galaxies is distorted, smeared, and duplicated, astronomers can map the exact shape and location of dark matter clouds, even though they cannot see the matter itself. When we map the universe using gravitational lensing, a breathtaking structure emerges. Dark matter is not just randomly scattered. It forms a gigantic, interconnected web that spans the entire cosmos. We call it the cosmic web. Imagine a vast network of glowing filaments, like the neural pathways of a giant brain. The dark matter forms the invisible skeleton of the universe. Normal matter, the glowing gas and dust, is pulled by gravity toward these dense filaments of dark matter. And where these massive dark threads intersect, gravity pulls so much normal matter together that galaxies and galaxy clusters are born. Without dark matter, there would be no cosmic web. The gas from the Big Bang would have just drifted evenly through space. Stars would never have formed. Galaxies would never have existed. Without this invisible ghost holding things together, we would not be here. Dark matter accounts for roughly 27% of the entire universe. When you add that to our 5% of normal matter, we reach 32%. Which brings us to the biggest, most terrifying mystery in modern science: the remaining 68%. Dark energy. If dark matter is the cosmic glue pulling everything together, dark energy is the unstoppable repulsive force tearing it all apart. To understand dark energy, we must travel to the year 1998. Two independent teams of astronomers were trying to measure the expansion of the universe. Ever since the Big Bang, the universe has been expanding. But because the universe is filled with gravity, from all the stars, galaxies, and dark matter pulling on each other, scientists assumed that this expansion must be slowing down. They wanted to measure exactly how fast it was decelerating. To do this, they looked at a specific type of exploding star called a Type 1a supernova. These supernovae are incredibly bright and explode with a very consistent, predictable luminosity. By measuring how bright they appear from Earth, astronomers can calculate exactly how far away they are. They looked deep into the universe, expecting to find that the expansion was slowing. But when the data was processed, the scientific community was stunned. The expansion was not slowing down, it was speeding up. Accelerating expansion. The galaxies were flying away from each other faster and faster with every passing second. Some unknown, invisible energy was overwhelming the combined gravity of the entire cosmos and pushing the fabric of space-time apart. And it was gaining strength. Scientists called this phenomenon dark energy. And unlike dark matter, which clumps together in galaxies, dark energy is everywhere. It is a property of space itself. According to quantum mechanics, empty space is never truly empty. Even if you remove every atom, every particle of light, and every trace of dark matter, the vacuum of space is still boiling with quantum energy. Virtual particles are constantly popping in and out of existence. Many physicists believe that dark energy is the energy of this empty vacuum. As the universe expands, more empty space is created. More empty space means more vacuum energy, which pushes the universe to expand even faster. It is a runaway cosmic train. Dark energy is the dominant force in the cosmos, making up a staggering 68% of reality. So, what does this mean for the future? We are currently in the middle of a war between the gravity of dark matter, trying to hold the universe together, and the repulsion of dark energy, trying to tear it apart. Dark energy is winning, and its victory dictates the ultimate fate of all things. If dark energy continues to accelerate the expansion of space at its current rate, our universe will face a scenario known as the Big Freeze. Billions of years from now, the expansion will push all other galaxies so far away that their light will never reach us. The night sky will become completely, terrifyingly dark. The stars will burn through their fuel and die, turning into cold cinders and black holes. The universe will continue to expand forever, growing colder, darker, and more isolated until the temperature approaches absolute zero. But there is a second, even more violent possibility. What if dark energy doesn't just remain constant? What if the repulsive force gets stronger over time? This scenario is called the Big Rip. If dark energy increases, it won't just push galaxies away from each other. The repulsive force will become so incredibly strong that it will overpower the gravity holding galaxies together. The Milky Way will be torn apart. Then, the force will overpower the gravity holding star systems together, ripping planets away from their suns. Finally, in the last fraction of a second of time, dark energy will overpower the strong nuclear force. Every atom, every proton, and every molecule in the universe will be violently ripped apart into nothingness. Dark matter and dark energy. The cosmic skeleton that gave us life, and the accelerating void that will eventually take it away. We live our lives entirely within the 5% of visible reality, completely surrounded by forces we cannot touch, cannot see, and barely comprehend. But there is beauty in this mystery. The fact that we, as temporary collections of atoms sitting on a tiny rock, have figured out how to measure the invisible architecture of the cosmos is a testament to human curiosity. We are the universe trying to understand itself, one tiny piece at a time. If you want to keep exploring the unseen and the unknown with me, make sure to hit the subscribe button and turn on notifications. Leave a comment below. Does the idea of dark energy terrify you, or does it inspire you? Thank you for watching, and as always, keep looking up